Hi there, and welcome to another one of our release videos. My name is Dirk Leroy. I work with UCAMCO in Ghent, and today I want to give you a walk around of our newest or latest Integr8tor Nexus software release, which is the 2025.11. Now, as usual, I have made a small presentation that is going to help me take us through the story. But before I start, I would quickly like to switch to my Nexus integrator here, where I would like to launch a job that I will come back to at the time we have finished part of the presentation. So I'm just setting it off here in the queue. It's 6913, and as I said, we will come back to this one later on. Right, let's move this to full screen. What are the highlights in this new version? Well, there is one very new and very fascinating topic, which is the AI Xtract, a new AI-driven module that we present, which has been designed to help you extract product parameters. So all the things that you need for your quotation that we do not extract from the Gerber data, things like sizes, surface finishes, whatever. We present a new module which is going to help you extract this in an automated way. And we will have the opportunity to see this at work. That's why I launched the job a couple of seconds ago. Furthermore, in this release, I want to talk to you about the Python scripting, the extension that we have done to give you more flexibility in terms of automating your integrator workflow. That will be an item number 2. Thirdly, there are some productivity enhancements, which are always part of our releases. So we will see a couple of items there, what we have been adding in order to increase throughput or to shorten processing times. And as also a last tradition, I would almost say, there is always the admin corner where we update you on some of the stuff under the hood that might have changed. And this time, I'm going to briefly present to you the new Log4j, which is on board with this version, and tell you what this brings as benefits for your daily operation. Right, but the first and probably the most important item in this release is this new module called AI Xtract. And as it reads at the top there, this is an AI-driven product parameter extraction module. And what this is going to do, as I already indicated briefly in the beginning, this is a module which is going to automate the process of retrieving all the PCB technical requirements relevant for your quotation. It's the things that typically sit in PDF documents that are part of the incoming archive, and that will, sorry, and that will tell you what the desired Calder mask or legend is, the board thickness, the copper weights, if it's going to be delivered, the PCB is going to be delivered as a one-up or in an assembly panel. I mean, you name it, you know all of these parameters. I'm almost convinced that many of you have already this sort of setup in their current systems, whether it be Cockpit or Nexus. And in theory, that doesn't change. What comes on top of it is a module which is going to help you go through this documentation in an automated way and take away part of the burden that people now go through to scan through all these PDF documents and look for the relevant information. So that's what it basically does in a nutshell. It is going to scan the PDF files or other unstructured data files that happen to sit in the incoming archive. So it's mainly PDF, but there are a number of, how I say, other file types that we can also do the analysis on. What the module, the AI Xtract module, will do is it will examine these files. Let's stick to the PDF files for the moment to make it simpler. It will examine these PDF file or files that are in the incoming archive from your customer, and it's going to examine them for your choice of quotation relevant board characteristics. So it's not going to do like a generic summary of what is in this documentation. You have your set of very specific parameters that you're interested in or need to make your quotation. And this module is going to specifically scan for these documents, for these parameters that are of interest to you. Now, the combination of these two, so the scan of these PDF files and then taking out the relevant bits and pieces for your quotation system, that is going to be presented. So these results are going to be presented in the technical requirements editor, which is one of the editors in our Nexus user interface. And inside there, we have added a sort of dedicated view, which we call the AI view, which is going to help us present the results of this scrutiny for final verification and acceptance by an operator. This is, by the way, a screenshot on the right here of this AI view, but we will have an opportunity to come back to this later on. Now, once these results from this scan, they are there, what this AI view then offers is a set of sophisticated review and validation tools for accepting or refusing or overwriting any of the values that were found in the documentation by the AI Xtract engine. I think, as it should be, this module still leaves the final decision to a very large extent with the human, which is in front of the interface. And basically, what we do is we analyze these PDF documents and try to find everything what is relevant in there. We put it into this user interface as you could say suggestions, but then the final decision is still going to be with the person operating the system. The specialties of this validation and acceptance system, one of the most eye-catching ones, I would say, is that for all the information that we have extracted from PDF documents, what we do is we are forcing the AI Xtract engine to sort of validate its own answers, in the sense that we want to make sure that what comes up here is not just a matter of coincidence, a word that was picked up, but we force the machine actually to sort of indicate, look, this response that you have given, in this case the PCB thickness, how sure are you about the quality of that response? And the machine is indicating this with a sort of traffic light system, where the green dots that go with the value indicate that it can be taken for granted that this is going to be exactly what we were looking for. The orange one are, yes, it's probably going to be what I said here, but you do want to have maybe a second look. And then the last one, the red one, is being put there in case a response, an AI provided response, is given, let's say, without too much certainty of the quality of the answer. So in terms of validating the responses from the AI engine, this is going to give the operator a real easy aid to sort of understand, okay, this is something I need to look into a little bit more closely. And maybe these green ones, and certainly after some time, after you build some experience, these green dots, basically these can be taken for granted and can be accepted automatically, more or less. Another very fine feature of this module is that not only it will assess the quality of the answers, the AI Xtract engine that is, it will also provide on-demand contextual information as to where this response was found, and we will see a couple of nice examples of that later on in the hands-on demo with the job that I have just just launched. But just to give you an idea, it's the sort of system by which if you click one of these values that you will get an explanation as to if you go on this page there and you look in this section there, I found this, and in my opinion, being the AI machine in this case, in my opinion, this is really what you're after. Another very fine feature of this new module is that it's going to help you convert exotic value unit pairs from the documentation to a suitable unit of measure that you have set up yourself for your own parameters. The copybook case here or example is that copper thicknesses in the documentation, they come in all sorts of imaginable and unimaginable ways. There are different ways of expressing it, not only between mils and millimeter, the imperial and metric systems, but also in the case of this one, you have the copper weights, really the ounce per square foot, sorry. So this can be in one document, it can be like this. In the next job with another PDF, it's going to be different. Now what we do is we allow the AI extraction engine. We just allow it to extract whatever it finds there, and it's going to return us really the results that were found in the PDF documentation. However, when it comes to accepting it, there is going to be validation routines to interpret these numbers and maybe the indications of the unit, and then to convert them to really the unit that you as a fabricator would like to use. In this case, the base inner copper thickness that you see here in the screenshot was set up to be in microns. So whatever is going to be the value and unit specification that was retrieved from the PDF files, that will be converted to the suitable unit of measure for you or for your other systems, your quotation engine, for instance, further downstream, which is going to use this value and will need to understand what this value is expressed in. So that's all automated to make sure that the values or the values that you have collected or that are being passed on to the next module, in this case, maybe the Excel macro or the quotation engine, that these systems downstream are going to receive the information that they expect to receive. There's a second screenshot here which comes from scrutiny of one PDF file where the finish thicknesses, for instance, are expressed in bigger than something which is in microns, and where the base copper is then expressed in, so the copper weights, the ounces. So that is being transferred and converted to the unit of measure that you have defined for each of these fields. That basically ties in very closely with something else, which is part of this module, and that is that it's going to prohibit what we call nonsensical values to go into the next step. The purpose of this whole exercise is that your QED report, your QED PDF or your QED XML is going to contain a section with, I would call it, clean data. And we will ensure that this data is clean by using a comprehensive data type checking system and user interface alarms. What it means is something that you see illustrated here. Let's say you have a layer count parameter that you would like to extract from the PDF document. If for some reason the AI extract engine is going to mess up completely and he would be tempted to write something like this in here, that the layer count is 2.4 millimeter, there will be a graphical alarm to start with on the field itself. So some sort of warning sign that is going to attract the attention of the user in that whatever value that is in here does not correspond with the rules that were set up with this parameter. So at the time that we are setting this up for you, we will say that the layer count field can only have integer numbers, for instance, and it cannot have anything in front or a decimal point or a comma. And as long as the value does not comply with the rules that were defined for layer count, then first of all, you would have this visual graphical feedback. And if an operator chose to ignore this and try to save the work anyway, then he would actually be prohibited from making this save just because the value in there simply does not comply with the rules that were laid out previously for this particular field. So that is going to make sure that whatever goes in QED PDF and QED XML is going to be, as I called it earlier, clean. So the values in there, that they are basically usable for the system which is next in line. The same module, AI Xtract, also has a system that caters for both mandatory and optional parameters. In many cases, we see that you need a basic set of parameters in order to be able to make the quotation. But if there are a number of other parameters, optional ones, that you're able to fine-tune this quotation better. Now, for every parameter that you set up or that we set up in AI Xtract, it can be defined that this parameter is a mandatory one or an optional one. If it's mandatory, again, there will be no saving possible as long as this mandatory parameter does not has received a valid value. For an optional parameter, it's either you fill it out or it's not filled out. Yeah, so that's the difference between the two. On pretty much the same level, there is also the possibility to have these default values. In many cases, you might want to have information for your quotation system that is basically very rare or rarely documented in a PDF. I mean, the example here in the screenshot is you would like to know what the end application for this PCB is for. Now, there aren't too many PDFs which are going to specify this. There is many other cases like the comparative tracking index or the TG or all these material parameters. You might find them useful if they are part of your information for further down the road. But in all honesty, the cases or the data sets that come in with this type of information included are actually not that common. So for those cases, what you can do, again, it's a can do, it's not a must, but what you can do is for some of these more exotic or rare parameters that you say, okay, if nothing has been found in the PDF documentation for this particular parameter, then we will assume a default value of something. The one that springs to mind is a TG. Well, if nothing else is specified, the TG value will be set to 130. That sort of thing. So that's the part on the mandatory and optional parameters and then their default values. Mandatory are marked with this little asterisk here. So later on, if we have a look in the job that we processed, the ones with an asterisk, they are the mandatory ones. If you see a value preceded by a D in this yellow circle, then that means that this value is actually a default value. So nothing has been taken from the documentation. Another very important and actually very nice feature of this AI Xtract module is the fact that it can handle incoming documentation in different languages. So whether your customer is sitting in Spain, in France, the other side of the world, and he provides his documentation in whatever language, basically the original language, the original PDF document goes to the AI extraction engine, and what comes back will be a translated value. Yeah, so that is actually built in and comes as part of the AI system. You will agree with me that a number of the parameters that tend to turn up in the documentation, so in the PDF file, are sometimes overlapping with what integrator calculates during an analysis process. The typical case there is a PCB size or maybe a layer count. PCB size is something that very often you will find in the documentation. But on the other hand, it's also something that once integrator has been looking for the outline and has established the correct outline, from there it will extract also from the Gerber data what the PCB dimension is. So what you can do with this AI extract system, and more particularly in the AI view interface in the technical requirements editor, is that you can have the two possible values or the two detected values um, visualized, I would say side by side, but in fact they are underneath each other, so that you as a human can sort of say, okay, this is from the Gerber file, it's 520, and also apparently in the documentation, there was a 520 for the PCB X size, for instance. So it's probably going to be 520 millimeters indeed. Yeah. So that really is, of course, a feature which is possible for the items that we calculate in Integrator. We cannot do this for what was I referring to earlier, the TG value, because from the Gerber files, we are not able to extract any TG values. But for the parameters that are sort of, as I said, overlapping between PDF and the extraction from the Gerber data, that is something that, if you wish, you don't have to, but if you wish, this can be set up so that the two are actually shown one underneath the other, and that a human, if he has to make a decision, that he actually has the choice to say, okay, it's going to be the calculated one from Integrator, or it's going to take, we are going to take the one from the AI documentation because blah, blah, blah. I've noticed in the PDF that's what we want to do. The selection, whether it be from AI or calculated values, is something that we have incorporated by just clicking one of these two buttons here. So the one there in red, the AI, is what has come out of the PDF documentation. The white one, calculated, is something that has come out from the Gerber analysis from Integrator itself. And depending on the one that you want to click, we will take this value and put it here, or the other value and put it here, and then mark it with a checkbox to remind you later on which one has been chosen. This whole AI extraction process runs fully integrated in the workflow engine system, or it executes interactively from the AI view, the dedicated AI view and technical requirements editor. So the natural thing to do, of course, is that you just leave this running as part of the data analysis. There used to be a part only where we analyze the Gerbers. Now there's also a part where we analyze the PDF documentation. So it's actually very transparent. It's you. As I have done a second ago, you just launch the job, and the system will take care of the rest. And finally, final note, as I said before, this is an option, a module that we offer on top of the technical requirements editor. So it is available as a development in Nexus. If we want to summarize this, this AI extract module is going to automate the collection of all the board's technical characteristics. It's going to scan through typically the incoming PDF files. It's going to go and look for your choice of board characteristics, that you find relevant for your quotation, so the list of parameters that you have defined beforehand. The result of this scrutiny, I would say, is going to be made available in a dedicated view inside Technical Requirements Editor, the AI view, showing the results from the scan through the PDF files. Then there is this set of sophisticated validation tools that will allow you to make a final decision on what value you want to actually go into your QED PDF or QED XML file. There is a system with the traffic light system to have the AI machine qualify itself, the certainty of its responses. And there is the contextual information function, which is going to allow you, if you click on a value, that the system will tell you where it found it and take you to the or let you go to the place in the PDF file. The unit conversions, so whatever unit is in the documentation, we will convert to the unit that is specified for the parameter that we are looking at that time. There is this whole system of data checking that is going to make sure that no nonsensical data is going to find its way downstream. That's being supported by these user interface alarms for inconsistencies whenever maybe also an operator, a human, can make a mistake and thinks he's in field A, but he happens to click on field B and then types in something incorrectly. So that will be flagged as and when he is trying to do this. The system for mandatory and optional parameters, depending on what is your basic set that you really require to make a quotation. The system of default values for anything which is exotic, that you can have the ability to do the default value. The side-by-side or below each other display of the values that overlap, so a characteristic which can come from Gerber, but which can also be documented in the PDF file. The fact that it's multilingual, of course, that it can do the analysis of documents which are in a variety of languages. So if you would bring this down to the core benefits of this module, what can it bring you or how can it help? Well, we definitely believe that it simplifies the process of collecting this information massively. It is, of course, very nice that it integrates seamlessly in the existing workflow engine process, so it's basically a natural thing. As a result of this, this extraction of this information, these parameters, can also, just like a layout analysis, is capable of running 24/7 unattended, because it's just part of the it's just part of the workflow engine system and the analysis that we do. And we believe that this will shorten the time to collect your quotation data. That will be shortened considerably. It also guarantees a smooth and error-free data transfer to the systems downstream, as we said. As a result of that, because we are doing quite a lot of checking and making sure that the data that goes out from Integr8tor is clean, this reduces, of course, the need to have all the checking and the validation of the incoming data on the next system. So in your Excel macro, for instance, if you can rely on the fact that the number of copper layers will always be an integer, or if you know for sure that the value you are going to be given for copper thickness is always going to be the one in micrometer, then of course your receiving application doesn't have all the logic and all the whistles and bells to deal with the various possibilities of units and thicknesses and God knows what. So there is definitely also a benefit for the part of the application which is going to receive the data. All the tools to make the final decision and to see what was collected and where to go next, that all sits in a very convenient and industrialized user interface, which is this AI view in the technical requirements editor. And last but probably most important, this is not something that is going to make blind decisions without anybody knowing. What we do is we collect whatever we gather from the PDF, and then, as we will see in a minute, there are systems for automatic transfer from what has been collected to the final choice. But in essence, the final decision is or lies always with the human. That, I think, is the point where I want to return to this job. It was the 6913. What I'm going to show here, or what you will see here, is basically, how would I call it, a light version or a light setup, not a light version of the package, but the AI Xtract package in a sort of not the basic form, but in a lightweight version. What's the lightweight version about? Um, you see here on the right-hand side, on the left-hand side, sorry, the column with all the parameters that I have defined for the system. On the right-hand side, there is a column that reads proposed values, AI or calculated. So these are the proposed values. And in the middle between the two, there is a column which is called accepted values. Um, it's basically the accepted value that is going to be the one which will go onto the QED PDF and QED XML. And as a result, that will go further to your Excel macro, your quotation engine, ERP system, whatever you link to next. Now, what is the light setup in this case? You see here that we have values in the third column, so the one that we have collected either from the PDF document with AI extraction or the calculated values. I have set up a number of parameters that we say, okay, I want to take it from the Gerber analysis. But you see no values in the middle. You see a lot of exclamation marks here, but no values. So that's basically, that could be an initial setup. If you start with the system and you want to get comfortable and get a feel for what it does and what it responds, then maybe this is a good setup. I'll take you to the same job in a second, where I have used a more extensive setup, which is going to do some extra automation in terms of passing a number of these parameters automatically to the middle column. What would be the thing that we want to do in this simple setup? Well, basically, I could click on the first parameter here, which is defined as the solder mask color. And as I do, you see that one of the documents, the PDF documents, comes into display. And because I have clicked this value here, it now tells me that under section 13, there is something that reads solder resist, single-sided, top white, blah, blah, blah. So if I would go to this section 13, which is here, I'm going to zoom up a little bit. We were looking at the color of the solder mask. So in here it says solder resist, single-sided, top color white. So it has extracted, well, first of all, it has interpreted this line or this piece of information. We call it solder mask. Here it's called solder resist. If you look at another one here for our setup, we call it legend color. In the documentation, it's referred to as placement print. So this AI extraction module is actually just more than a search for word in a document. It actually does the interpretation of what is written in the PDF file and tries to work out which is which and how that would tie up with any of these parameters that I have here. So I see here the white. White is there as well. If I was now doing this for real, then maybe I would click this AI button, and that would mean that the value white is accepted by me as a human as the one to be. If I would click on the next one, the text would read the same sentence notes, color bottom not applicable, while the solder resist is specified as single-sided, indicating there is no solder mask on the bottom side. So that's basically what you see here is a motivation from the AI extract machine, why it has put a no in here. So from scanning and interpreting this data, it has not come to the conclusion, or it has come to the conclusion that there is basically nothing being said about solder masks on the bottom. It was just single-sided and color top. So from there, it makes this decision. And so on and so forth. If we do the black here, it will still say in the same section, there is this thing called placement print, and it's set to black. So there you go again. I'll click on one more here. The surface finish has been retrieved as LF, so lead-free hot air solder leveling. where it says the surface finish is basically on the same section here, and is referred to in the document as hot air leveling unleaded. So it knows that in my list of choices here, I have a whole bunch of them, which are basically the ones that you know from Integrator. So it's capable of actually mapping this the same notation. Yeah, we're talking about the same surface finish to match that or to map this onto the value, one of the values that I have in my list of predefined ones. Yeah. So that's basic stuff. When I come to this one here, the PCB X and Y size, you see that for these two, I have set them up to feature both the AI extracted value as well as the value that was calculated from the regular integrator analysis, which also does the board extraction. And as you can see, in this case, they are the same. If I click on this value, I will get the message here that in the mechanical dimensions, here, this is where it found the PCB dimension for the first one. And of course, the calculated one is derived from the PCB data files, the PCB data files being the Gerbers that have been analyzed as part of the whole process. So this is one of the examples where one of these overlap cases where a certain parameter is documented in PDF, but can also be extracted from the Gerber data. Again, as I said before, the fact that you display both of them here is just something that you decide to do, yes or no. If you are just comfortable with, I don't know, just the calculated size, to always have the calculated size in here, you can actually set this up so that there is no AI research done for the PCB X and Y dimensions, and that you always go with the calculated sizes from Gerber. So this module actually offers you all this flexibility to do this sort of thing and to really tailor it to your needs. And as I said, probably you will want to get some feel for how this behaves and what it does and what it can do. And once you have gone through this initial stage of getting comfortable with it and finding it to be reliable, then at that point you might go to the next step and automate your setup a little bit more. And that's what I wanted to show you next. Okay, before I go there, let's just assume that I would click close here and that I want to save these parameters that I have just done. Since there are too many, or since there are still a whole series of exclamation marks left, I will not be allowed to do so. And so I cannot just save this data to the database as long as these mandatory parameters here, the one with the asterisks, have not received any value. So therefore, I'm going to quit here. Let me see. I think this is the same job, but done from a more automated setup. So this is this was run before this session started. And as you see in this case, we will have the same results. So all of these values that were coming from either the PDF analysis, which is the ones with the red marking here, the AI, as well as the calculated values. It's the same sort of setup. But in this case, what I have done is I have incorporated in the setup for this particular installation, you could say, I have allowed it to actually transfer values automatically from the proposed column to the accepted column. There is a whole system in there. You can define, okay, if we look at an AI extracted and a calculated value, I always want to use the calculated, or you can say I want to use this red light traffic system if I have values that are that have come out of an AI analysis, but they have a green dot. So the engine itself is pretty sure that it's going to be the right answer or the right value. Then you can set up a system in which you say, okay, everything which is green coming back from AI can go automatically in the in the middle column to be accepted sort of by default. Yeah. Nonetheless, of course, there is still the possibility to actually click through them, and the ones which are coming from the documentation will be explained here as we saw before, and then can be retrieved in here. By the way, we are currently already working on a version which is going to, other than just this textual information, which will also be putting a highlight in the document itself, but that is still in development, so that will become available probably for our next release. Right, I think that sort of closes it for the AI extract. And that brings me back to the presentation. If I take this from the current slide, I now want to briefly talk about the Python scripting that we have added to this version. Maybe just a quick background for those who do not know. Python is basically, or has become, a very popular programming language. It's being used quite extensively. It's field proven. It's well vested and accepted. So it's basically a programming language which offers a lot of nice features, which is probably demonstrated also by the fact that a number of leading web framework providers have actually taken that route with Python to do their developments. And as a result of all of this, there is actually a very broad community of Python fans worldwide, which are using this on a daily basis. So it has, you could say, Python has become the favorite ecosystem of quite a large audience who are into programming, automation, or into scripting. So what we thought is that, okay, Integr8tor is renowned for its automation possibilities. I mean, the actual process itself is automated, let there be no misunderstanding about it. But when a job finishes processing, the data that has been generated at that point must go elsewhere. Maybe images must be shared, maybe people must be informed that a job has come to a conclusion, all that sort of thing. So the post workflow automation is something that many of you, I think, have undertaken to put in place. And this is only one of Integr8tor's capabilities to do the automation. You also have the possibility to actually intervene within the actual workflow process itself, where you can steer a job or modify a job underway while it is going through the analysis. All of these things have been possible before, but what we have now is that the steering of this whole automation at the end or within the workflow has now become accessible for this whole audience of passionate aficionados, as they are called here. And that, of course, creates a whole lot of opportunities for business flow optimization and process automation. Because, as I said, this whole community is very familiar with the Python language. And if you have somebody in your company who is well vested in this, for him it now becomes sort of self-evident that all the automation that he wants to do or can do, now that he can do it from his favorite tool, from his favorite programming language, the step is probably less a bigger one to take. Now, what we have done in this release is basically we have swapped the Java virtual machine, the internal Java virtual machine in which Integr8tor runs, has been changed or upgraded to a product which is called Graal VM. And what that does is basically it contains an extra layer, you could say, on top of the regular Java component, which is typically part of the Java virtual machines. Now, what this extra layer does, it is actually bringing all of Integrator's programming objects and methods, so the things that you do to get hold of an Integrator job programmatically, and the methods that you have to extract information from this job, or the methods that you have to change any information for that job. This all now becomes directly available from within Python scripting, from within Python automation. So the variable which represents a job now exists in this Python environment just as well as it existed before in our other programming language. So what that means is the home-written Python automation that may exist with a number of customers can now become basically integral part of the whole workflow process. And that is, of course, a very nice feature to have in the sense that you're actually running this whole system, not just the analysis of the Gerber data and the PDFs now, but also at the end of the process, for instance, that from your homegrown automation, you can actually start moving data to a file server or a device, I don't know, an ERP system via HTTP, or all these nice tools that allow you to integrate one system with another. This can now all be done from Python automation and Python scripting. And as I said before, what it uses there is basically the existing automation hooks, as we call them. Yeah, I refer to these trays when a job comes at the end of the processing. It falls in what we call a certain tray. There are many different trays, but when it comes to a successful conclusion, the job will go into a particular tray, and to that tray you can write some home written automation yourself, and so that automation can now be done in Python, and it's basically fully transparent for anybody who's going to have to use this. So this automation will just run because it has been defined and set up like this, without the salesperson, so to speak, who launched the incoming archive being aware or having to do anything special. So with this extra layer in the Graal VM, you are now in a position that you can query, modify, or update your integrator jobs from within these Python scripts. You can pick up the QED results, again from Python routines, and then move them to elsewhere, the images, the PDFs, God knows what. So all this from this home written Python automation that you have, and then steer the whole process, the post integrator process, almost steer it from within your own scripting, without having this to set up as a separate entity or as a separate application between two other systems. So that basically makes it a very clean and powerful solution. Now, let's not forget also, some versions ago, the integrator, or we introduced the REST API for integrator. That too, this whole set of REST API commands is accessible from your Python scripting. And if you combine all this together, I think you end up with an extremely powerful and agile automation asset. Now, I've mentioned that the Graal VM is the successor of our previous Java virtual machines. But having said that, I think it's important to know that the Java component within this new Graal VM is basically the same as the Java version that you had before. In our previous releases of Integrator, we moved to Java 21, the long-term support version, and that inside the Graal virtual machine environment, that is still the case. So that means that all of your existing automation that you have developed already and which is Java based is simply compatible with the Graal VM. So there is nothing extra to do there in order to make it go from a previous version to this one. I also explained that this Python scripting, it's an alternative automation feature on top of what we had before. And what we had before, the way to program an integrator or to automate an integrator was Bean Shell and the Java scripting language possibilities. Now they exist as before. So if you're not into Python, you can just continue the way you were doing. The Python scripting support is basically just an extra feature next to this. So from now on, you have the choice which of the two you would like to adopt. Also important to know is that this support for the Python-based scripting, is comes free of charge as part of your maintenance contract, so there is no extra license involved there. However, having said that, please note that the fact that you want to automate your integrator with your own scripts and integrate this inside, that the access to integrators, some of the integrator internal data objects that you need to access in order to retrieve information from or to set new information to, that this automation feature is licensed in a variety of ways. But again, that is something that has existed for the past, I don't know, maybe 10 years, if not longer, the whole automation system and how it's licensed there. So that remains unchanged. The fact that you can talk to the integrator, so to speak, in a Python language, that is something which is not licensed and which is available as of this version. I've just mentioned one URL here, but as we explained before, there is a whole community. There is there's a massive load of information. If you want to get acquainted with what it is, GraalVM, and how it links with Python, feel free to do a search or a look up on the web. That brings us to the next item, which are these productivity and efficiency enhancements. One item in there is the automated SDKX input. As boards become more complex, there is growing need to adhere to pre-described material and stack-up instructions. So the designer basically at the time of designing the board has already fixed it's going to be Rogers material or it's going to be this, and the isolation distance between layer 2 and 3 is going to be that much, and blah, blah, blah. So all of this thing for the type, for the more complex type of boards, this we see gets prescribed more and more often. Now, what we also have seen is that Polar Instruments, their software is actually quite often the favorite tool for designers to use at the time of the design of the board. I don't know, for impedance calculation or simulations or whatever. And as they are using this Polar Instrument software already, the output format, or one of the output formats of Polar, called STKX, is something that we see in a growing number of cases in the incoming archives. So the tool that was used during the design of the board and that is capable of outputting the stack-up information, the material information, we see that a lot of the archives that are coming in have this STKX file included. So that's why we thought, well, it might be an idea that from now on we are going to actually look actively in an incoming archive, that we're going to look actively for these Polar STKX file. And if we find one, that we are going to read it in and make it part of the whole analysis process automatically. And that's basically what you see here in the screen dump on the right from, I think, let me check, I think I have this job online as well, don't I? you get out here. Yeah, I think this is the one. So in this archive that we've processed here, there is an STKX, and basically what that has produced is, if I open this just from the first run, without any extra toing or throwing, basically you get all of this information included in your analysis reports, both the PDF with the display of the stack up and everything that goes with it, but of course also in the XML file. If you use the QED XML file, all of this information about the material, the thicknesses of copper, the isolation distances between copper layer, this is all part of your integrator analysis. Sorry, I'm getting lost here. And that means, of course, that if this data is in there and we pick it up automatically with one run, you basically have everything. In previous cases, you would first do a run and then see, oh, there is STKX information, then maybe take it to Polar and Sidestep and use the software of a Polar that you can link to Integrator. But in this case, if we find them and the STKX license, input license is available, then this will be part of the first run, which is again going to shorten the process cycle to get to the analysis results. In something of the same context, you could see the second one here, the plating information from the Echelon drill file headers. Nowadays, many of the CAD systems, they produce a more rich, I would say, Echelon file, in the sense that they very often contain headers as sort of comments that are going to have additional information about the tools being used, not only the diameters, which we have been picking up for time immemorial, I would say. But with this version, what we are going to do specifically is scan these Echelon headers to see if there is any information about the plating of a tool. Plating or non-plating of a tool is relevant and very important. If you think of, for instance, the exposed copper and the surface finish, the surface of the surface finish, so the amount of square millimeters of exposed copper that you have. And it also includes the barrels. It is, of course, important to know whether a barrel is going to be plated, yes or no, because that is going to have an impact on the exposed copper area, so for your copper area calculation. So what we do within this new version is we will go and recognize these header and filter the relevant information from it. It's not that we are going to blindly believe what is in there. This whole system works with something with weights, and what we do is if this information about the plating is present in a header for tools in the Echelon file, then we will give that sort of a weight, an importance to be taken into account then as we decide whether a tool is going to be plated or not. So what we have seen is that more jobs come out with the intended drill tool plating once we have adopted this system. Again, the bottom line is the same thing. If you have this information right the first time, then basically the job runs through one time from A to Z, and the information is there and it is correct. So you don't have to go to an editor to sort of change a plating characteristic or something else for tools, and then have a partial rerun, which again reduces the number of reprocessing cycles and produces a shorter job turnaround. So that's in the area of the drill input. Another one that we have taken a look at is these. You know that many of you know that and are actually using the email submit system. And what you have there is you can submit an email to Integrator and attach a zip file to it, but you can also attach multiple zip files to it. Now that is nothing new in itself. But what happens is if you have multiple zips attached to the single email that you send to Integrator, that is going to create, as an example, you have attached 3 zip files to the email. That is going to create 3 job entries in the job queue. So you will have your job for zip A, zip B, and zip C. Now, that's all very well, but a number of the parameters that have gone along with this submit through the email may be different for zip A compared to zip B or zip C. And that is why it is important, particularly for people who do automation afterwards, that at the end of the analysis that they are still able to say, okay, this entry in my job queue, it came from a multi-zip email submit. Because that allows them to have a closer look at these 3 jobs that came in from one email, and make sure that all the parameters for further down the road are the way they are supposed to be, and that there are not any differences to be taken into account between the 3 jobs. Now, as a human, normally, if you check these jobs, that is something that would be part of the human logic and the work that a human has to do. But for automated processing, we are now basically tagging all these the entries that have arisen from an email submit with multiple zips. So that makes sure that the job flow control or the trace scripts that come at the end, that they recognize a job in the job queue as being one that has been submitted in this particular way, and that then the rest of the flow can be steered accordingly. Another nice one is the board thickness from ODB data sets. The board thickness, again, is one of these vital things for a correct barrel surface, the one that we mentioned with the plating and the non-plating a minute ago. And in a standard scenario, what will typically, or what we see typically will happen is, of course, you don't know the board thickness in advance. It is typically one of these parameters that sit in these PDF documents. So people will give it a standard value of, I don't know, 1.6 millimeter or 1 millimeter or whatever. And then later on, after having looked through the PDF documentation, they will modify this. But again, as they modify this, it may mean that a partial reprocessing of the job has to take place, because the original barrel surface was based on, say, my 1 millimeter assumed thickness, whereas now, after reading the documentation, it turns out that the thickness of the board is going to be 1.8. So that needs to be changed then. Now, what we have seen is a number of you have sent us ODB data sets which have the board thickness included in one of the file sets is the attribute list in the ODB structure. So what we have done with this version is that when we detect the board thickness being present in the ODB file, that we will take it from there. And again, the same reason or the same motivation as the previous cases, this eliminates the need for partially reprocessing the job after you have modified the board thickness, because the board thickness will now be recovered from the incoming ODB data set as the job goes through first time. It also makes sure that, for instance, errors, typing errors or other are going to come into this process if the thickness is specified in the set, the incoming data set itself. Take it from there, and nobody else has to do anything special to make this okay. Another item in the ODB context, this time on the job export side. So at the time that we export the ODB, you as a board fabricator may run your integrator using a system where you're going to run the analysis with drill hole sizes rather than finished hole sizes. We have this system, have had it for quite some time, where the incoming data typically is finished hole sizes, but for manufacturing purposes, you want to move these or you want to convert or change these drill sizes or these diameters, sorry, to drill sizes. Now, the people who send this original data, they are mostly unaware of this, I'd call it hocus pocus, with these diameter increase that you do as a fabricator. And if ever it comes to the point where you need to send back a data set to your to the original client, it can be sometimes very confusing if you need to or if you have to start discussing things, queries that need to be sorted out. Look, your ring here is not enough because of this and this. You have this drill hole 0.75 here, but of course in the original design this 0.7 used to be an 0.6, for instance. So in order to facilitate this sort of process and conversations, what we have done is we have provided a possibility to include inside one TGZ export, so one TGZ output from the from Integrator, that within the TGZ file you will find two different steps. One is being the data with the original drill holes. The step next to it is going to be the one with the increased hole sizes, so that the receiver of your TGZ package at least can put two and two together and see which is which should hopefully facilitate communication a little bit. One of the evergreens, well, one of a number of evergreens, is the stackups. Again, this version comes with a revised stackup recognition engine. Again, we are grateful for the examples that you keep sending us where we can improve. The goal or the motivation after behind this, the reason why we keep doing this is, again, if we have the setup, or if you have the stack up rather, correct the first time around, you have a shorter, as a fabricator, you simply have a shorter processing time. You know that when the job comes through and the stack up is correct, all this data that sits in your QED files, PDF or whatever, that they are going to be correct. If the stack up is not okay, it needs to be corrected, and the whole process has to start all over again. So as I said, we are very grateful for the for you sending us the cases where we missed, because it gives us an opportunity with every release, as I said, to improve this stack-up engine. The same is basically true for this part. It's the recognition of the edge connectors. This is basically a project that we started with the previous release, and that has had some follow-up in the current release, where we are now also looking and picking up edge connectors, sorry, of a more sophisticated kind, like I don't know what we see here in the screenshot. There is this one accompanied by these, and here in this area, in this row at the bottom, you see also different sizes and shapes combined with each other. So we have again put in quite a lot of effort to go and detect these more intricate and sophisticated edge connector configurations. And the same applies here. We are grateful for the material that you let us have in that respect. And we are looking forward, if you care to send us any others that you feel we might do a better job on, then please feel free to do so. And the number 3 evergreen is the one with the drill span recognition. Again, the same story. If your drill span is incorrect, inevitably you're going to have a partial rerun of a job, which is going to cause a workflow to be taken for a certain time, a workflow which can then not be used for analyzing a new job. So the usual story. So there too, we have reworked our engine to again provide superior recognition of through-hole, blind and buried and back drill file configurations, using either extended recognition schemes for layer names. There is always ways that people invent to name their back drill layers, for instance, in a certain way. Now we sort of consolidate all this information, and that is typically one piece of the engine where we will work on, and that we will enhance based on the on that sort of information. But not only the layer file names themselves, the drill file names themselves, also the metadata files, so the text files that basically come with the archive and that explain which is which and what is the function of this. And here too, the same applies. Feel free to let us have any cases that we still miss out on. Lastly, I think Admin's Corner, just a very brief word on as a supplier of software, of course, we are committed to helping you to run a safe and secure software environment. And in this 2025-11 release, we have included a major update of the Log4j logging program. We've updated it to the version 2.25.2, which at the time that we write this is the most recent release for this program. To reassure you, maybe you picked this up some time ago, year or longer. Log4j came into to the news, and it was ill-reputed at some point, and it had lots of problems. So what they did at Apache is they have taken care of all these concerns. And with the new release, the new version that they have, all of these previous concerns are put to rest. And it also shows that many of you probably undergo these audits on a yearly or 2-yearly basis, where the software tools that you use are being scanned either internally or by external auditors. And where the version or specific versions of Log4j used to be on the list of suspected tools or tools to be avoided. The version 2.25.2 is basically one that will stand this type of audits and security. So it's accepted by accreditors and auditing instances, just to make that clear. Other than that, there are the usual code fixes, of course. I'm not going to list them here, but do find them on the release page. Clicking your way through, you will see what else we have corrected in terms of software problems that you have kindly brought to our attention. And I think this brings me to the end of the presentation. I hope you enjoyed it. Thanks again for watching it. Stay tuned. We will be back for more in the coming months as we prepare for the spring release. Okay, thank you. Take care. Bye bye.